See Lindelof videos, rational exponents in simplest forms, number 2, the second one here, and we're asked to simplify the cube root of x over y to the eighth power. I want to just show you something to show you why this is a little bit of an issue. Depending on what level of math you're at, this may or may not be an issue, but at the higher levels of math, we are not supposed to have this. And let me show you what this translates to. This translates to the cubed root of x over the cubed root of y to the eighth. And in a perfect world, math convention says that you should not have a radical in the denominator. So where possible, you should get rid of that. But if we look at this for a second, the cube root of y to the eighth is not perfect. It doesn't clean up well. So we just do this little trick, frankly. Remember that the root of a times b is the same as the root of a times the root of b, as long as those roots match. So I'm just going to kind of mess with this a little bit, and I'm going to do this. I'm going to rewrite this where my goal is. I'm trying to get rid of this radical. See if you can figure out what I'm doing. I'm trying to get rid of this cubed radical here at the bottom. So what I'm going to do is I'm going to rewrite this. I'm going to say I have the cubed root of x over the cubed root of y to the eighth power. If I had y to the ninth power, if you think about it, if I had y to the ninth power, the cube root of y to the ninth power would be y cubed, wouldn't it? So that would work. So this is what I'm going to do. I'm going to multiply the numerator and denominator by the cubed root of y over the cubed root of y. Start off with why this is okay, and why this is okay is because we are multiplying by 1. And if you multiply anything by 1, nothing changes. It's called the multiplicative identity, so we're cool with that. So look what happens here if we do that, though. If we do that, we get this. These radicals are the same. Cube root, cube root. So the cube root of x times the cube root of y is the cube root of xy. That's okay. The cube root of y to the eighth times the cube root of y to the first, right? Remember this rule. We have a to the m times a to the n is equal to a to the m plus n. That's the first rule of exponents, isn't it? So if I do that, I add these two things. I get the cube root of y to the ninth. The cube root of y to the ninth. Well, the cube root of y to the ninth is y to the third. And if that's bothering you, let me show you how that will work. So I'm just going to say is equal to the cube root of xy. This, remember, we can represent a radical as a rational exponent. So I can say that this cube root is the same as the 1/3 power. So what you see in blue here is what's in blue here. I just wrote it in a different way. So here's our y to the ninth, y to the ninth. We remember the second rule of exponents that says that if we have a to the m quantity raised to the nth power, we have a to the m times n. I've done tons of videos on this, so hopefully you've seen it. So we get 9 times 1/3 is 9/3. 9 over 3 is 3. So we would get y to the third power. And just given mathematical convention, this is a better answer. Why? Because we do not have a radical down here. We don't want radicals in the denominator to the best of our ability. So, you know what? Let's do another one really quick, just so you can see how this kind of works. Here's something that's just really simple to look at. Take something like this. Take something like the third root of 27q to the ninth power. We can say that that's the same as the cube root of 27 times the cube root of q to the ninth. 27 times q to the ninth is 27q to the ninth. What is the cube root of 27? The cube root of 27, of course, is 3. And what is the cube root of q to the ninth power? Well, it's 9 over 3, which is q to the third. So q to the third power. So just something to think about with these rules. This is not easy, but I'm promising you right now, if you get good at this, your ability to do higher level math will increase exponentially. So if you have any questions or comments, please let me know. If you haven't already subscribed, please do. Thanks.